Everybody, my name is Kyle Christensen, and this is my final project's Lab 9. First, I would like to show you my circuit, and just to give you an idea, it's supposed to resemble a racetrack, which we will see in processing and will make much more sense with conjunction with the circuit later on. But just to describe it for now, we have a finished flag on top of a servo motor that is combined with the potentiometer will rotate as I spin the potentiometer. It is connected to pin 13, which will take in the input that we get from the readings from the potentiometer at A0. It will output to pin 13, allowing the servo to move with the potentiometer. We also have 3 LEDs, which will start at 1, and then we'll move across to the next and the next one as I spin the potentiometer. This is also connected to pins 10, 11, and 9, 10, and 11. And also we'll take the input of A0, the reading we get from the potentiometer, and output the changing of lights. And just to give you an idea, as I spin the potentiometer, the flag waves and it jumps to different lights. And I spin it back. Now onto my Arduino code. As I just said, we take an input from A0, which is the reading from the potentiometer, and it's going to be outputted to pin 13, which is the servo motor, and then pin 9, 10, and 11, which are the different LED lights. In our void loop, I have initialized the potentiometer reading, which will come from analog read A0, and then from roboticsbackend.com, which helped me with the potentiometer with the multi-LEDs. They helped me initialize LED numbers equal to 0, and then initialize LED choice, and gave me this equation. And this equation will help me with a bunch of if loops that I have down here. As you can see, so if the LED choice, the LED number was 3, then you know the LED choice is 2, and that would be the else loop, which would have the first 2 pins on low and the third one on high, which would light one of the LEDs, the third one. If my LED choice was equal to 1 and I was on LED number 2, that would make the first pin low, the second pin high, and the third one low again, which would make the middle LED and the halfway point of the race car on high. And the same thing goes if my LED number is 1, and that means I'm on my first LED, and that means the first one is lit up and the other 2 are on low, which means the race hasn't even begun yet. And this here is my code for allowing for the servo to move at high and low, and I have a serial print LN POT, which is a potentiometer reading, as well as the string print LN, which will connect it to my processing code. To start off, we use code from GitHub from a prior lab as a baseline, set myself up and hook myself up with the Arduino. The big start here is under void draw. We change the array length to 1 and just initialize A1 as that first part of the array, which will intake the potentiometer value that I'm getting from the Arduino and make that A1. Here, under void draw still, I have borrowed code from openprocessing.org from Lavinia Chin, where she gives me a car image code. And here is all the code for that I took from her. The big thing that I changed in her code, because this car was stationary, was I did plus A1, which is that potentiometer reading. I put in each one of the X positions of the ellipses and rectangles that make up the car, so that when I spin the potentiometer, the car will move across the screen. And then another big piece of borrowed code I used from processingflowscience.com was this code to move an object without it kind of streaking across the screen and cleanly moving back and forth. And I use this code right here. And I will run it right now. As I run the code, you see the car at the beginning and the finish line. As I spin the potentiometer, we're at the halfway point. The second LED light is on, and you can see the flag is halfway waved. And then as I get to the finish line, the third LED is lit up, and the flag you can see has moved to its final position. Thank you.